Hi and welcome to another Dech Academy video. Here I have question 47. By the way, it's 3:48 a.m. and I'm making videos for you guys. So you guys should know that I care. So if I say anything that doesn't sound right, it's because of the time. But okay, I'm joking. Everything here is accurate. You know, I check my videos before I upload them. Here I have question 47. And it says the slant height of a cone is 5 centimeters and the radius of its base is 3 centimeters. Find correct to the nearest whole number the volume of the cone. Take pi as 2207. Now, you must have come across a cone. A cone is the following shape or object. You know, an easy way to draw it is just, a cone has a circular base and it has sides that taper to a point, but this is a cone, essentially a rough sketch of a cone, and this is the slant height, the length of this side, just from here to this top. Slant height. The radius of the base, remember the base is a circle, the radius of the base is given by 3 centimeters, so we know the radius of this circle is 3 centimeters, and they're telling you to find to the nearest whole number. I guess that's the challenging parts of this question, because it's giving you all the information you need. The volume of the cone. You know that the volume of a cone, or you should know, or you better know, if you're going to your exam, that the volume of a cone is 1/3 times the base area times the perpendicular height. The perpendicular height is different from the slant height. Here, we're given the slant height. So we need to find the base area, and that's determined by finding the area of this circle, which is the base, and the perpendicular height we need to determine. Let's start with the base area. We have a circle with a radius of 3 centimeters. The base area is the area of the base, which is the area of this circle, which is pi, given by pi r squared. And our radius is 3, so we have pi times 3 squared. We've been told to use pi as 22/7, so 22/7 times 3 squared, which is 9, gives 9 times 22 I'll use my calculator. Let's get 198/7. So we know the base area now. So all we need to know is the perpendicular height. Now, from this cone, you can draw a sort of front view of the cone. Imagine the cone was lying on the table. This is what you see from one of the views. And the slant height will be this side with 5 centimeters. The base, wow, I guess it's better okay, let's see how good I can sketch. So this is us. This is a table. And we have the cone on the table. Yeah. Now, I'm telling you that if you look from here, and you can test this at home, if you look from here, you look at the cone, this is what you see. You literally just see this outline. You see a triangle, and you see like a flat kind of surface, and this would be the table surface. This is what you see. You see a triangle. Now, the length of this bit I'm moving through, so I'll highlight that in red, is equal to the diameter of the circle, and half of it is the radius. So that means half of this is the radius, which is 3, which means this is also 3 on the side. But the key thing now is that with a cone, you can always reduce this. The triangle formed is always an isosceles triangle, and you can always reduce it to a right angle triangle by drawing a perpendicular line in the middle. So this is something you should know, or you must have come across, because you expect to know this. And you get a right angle triangle, and this is the perpendicular height, because this height here is the height here of the cone, and that's this height here. And basically you reduce your cone to a simple right angle triangle with an unknown height h, the perpendicular height which you're trying to determine, a slant height of 5, and you have kind of half of the base as 3. And using Pythagoras, 5 squared is h squared plus 3 squared. We're trying to find h. So you get 25 equals h squared plus 9. So 25 minus 9 is equal to h squared. H squared is 16. H is the square root of 16, which is 4. So now we know the perpendicular height. This height is 4 centimeters. So if you go back, the volume of a cone is 1/3 times the base area, which we've determined, times the perpendicular height, which we just determined. So the volume of the cone is 1/3 times the base area, 198/7 times the perpendicular height, which we just determined to be 4. And that gives 37.714. Number is 38 centimeters.